Audio Jungle. Audio Jungle.
What's going on, guys? Hey, I wanted to go over the quiz review with you. It's important, man. You guys watch the video. Take your time going through it. Let's ace this quiz with the tail end of this thing, and I want you guys to do really well. So, let's dig in. All right. This first problem right here, number one, has two parts. All right. It says, given the parent function f of x equals the square root of x, write an equation, write a function that transforms f of x into the following ways. So we're going to take the square root of x, and first we're going to have a horizontal shift right. Shift right 3. Okay, shift right 3. Then we're going to have a vertical compression by 1/2. All right, so the vertical compression, you know, that's outside 1/2. All right, then we're going to shift this thing right, which means -3. Shift this thing right. Okay, so here's our new equation, our new function. All right. Next, we have our f of x, and we're going to reflect it over the y-axis. All right, so if we reflect it over the y-axis, that means we have a negative x. All right, and then we're going to shift it down. All right, the negative for the y-axis, and then shift it up, All right, +5. Notice that it's not underneath the radical. All right, let's go on up 5, okay? Next, right here, it says, given the function 2x cubed minus 3, name the parent function and the transformations. Well, the parent function is right here. This is an x cubed function. All right. I mean, x squared function. Sorry, guys, x squared. All right, parent function. All right, it's x squared. Now, when we name the transformations, we have a stretch right here. All right, we have a vertical stretch. Vertical stretch by 2, and we have a vertical shift, or let's just say down 3. All right, vertical stretch by 2, which is right here, and down 3, which is right there. All right. Right here we have f of x cubed minus 4. Hey, I'm gonna go ahead real quick. Let me pause it. I'm going to put this graph. I'm going to show you this graph first on these two before I manipulate it. All right, guys. So hey, I went ahead and I took that equation x cubed minus 4, and I graphed it just so you can see the calculator graph it. Okay. Right here, the y-intercept is -4. 1, 2, 3, 4. All right, so let me show you real quick. Let's go back to our deal right here. All right, so I'm not the greatest drawer, so here we go, man. I sketched it. All right, so now we have that equation. All right, x cubed. Well, we have f of x, and we're going to go f of x minus 3. So that means I take this whole thing, f of x. All right, minus 4, sorry. And I'm going to subtract 3, okay? So when I do that right there, guys, that gives me x cubed minus 7. These are the only like terms, all right? So x cubed minus 7. We took the function and we subtracted it by 3. All right, so when you do that, all these points just move down 3. All right, so if I were to enter that into my calculator, you'll see that this went down 3. There's the parent function. And see that 1, 2, 3, it went down 3. There is our transformation right there. All right. So now over here for this next one, get myself out of the way. Right here we have the function. All right, but we're going to subtract 3. All right, so if we take that function, all right, and we subtract 3, that's to the x minus 3. All right, that's going to be our new function, okay? That's directly subtracted from the x, okay? So when we graph that, all right, here's what you get. Oh, you know what I didn't do? I put the wrong thing. Darn it. That should be minus 4. That's right. So y'all see how it shifted 3 units to the right. That's the only thing that changed. All right, it's down 4 still. All right, but this whole thing shifted to the right. All right, shifted to the right 3. All right, which is what we have right here. The whole thing shifted to the right 3, okay? All right, now let's look at this next one right here. All right, this is let x, or f of x, this function, guys, be this. Here's the function. All right, write a function that performs each transformation. So if I take this right here, and I want to reflect across the x-axis, well, that means the negative goes outside the whole function. All right. All right, and then we're just going to simplify it. That negative says reflect across the axis, the x-axis. All right, so distribute that. All right, so you get negative x cubed plus 2x squared plus 5x minus 3. So this right here would be the new f of x, all right, or g of x, all right. This would be our new equation, all right, reflect over the x-axis. All right, over here, we're going to take the equation, all right, f of x, and reflect it across the y-axis, all right, across the y-axis. So when you reflect across the y-axis, remember the y gets the negative, all right, the y gets the negative. So here, the x gets the negative. All right, so every x you see in this equation gets a negative. So you end up with negative x cubed minus 2 negative x squared minus 5 times negative x plus 3. And then, I don't know, all right, if your teacher's going to be satisfied with this. All right, for mine, we're going to simplify this. All right, we know if you cube a negative, it's still negative. All right, right here, if you square negative is positive, so you get negative 2 times positive x squared. All right, my fault, that's still cubed though, negative x cubed. Right here, negative and negative, since that's just one, a degree of 1, is going to be positive 5x. And then plus 3. So this is the simplified version. Your teacher might be perfectly fine with this, okay? And that's fine, you know. Now this one, all right, write a function that transforms this f of x by reflecting it across the x-axis and moving it 3 units to the left, all right? So the first thing I wanted to point out is this. We got to take this whole function f of x, all right, we're going to reflect it across the x-axis, and we need to move it 3 units to the left. So what we're actually going to do is this. I think the best way you have to remember this is you're going to take f of x, right? You got to have a negative f of x, right? Then you're going to move it to the, to the left. Move it to the left by 3 units, all right? So now take the negative. Again, you got to remember, this is the reflection of f of x. This will move it to the right, okay? So distribute your negative to the function to get the negative x plus 3. Oh, I forgot the fourth right here. X plus 3 to the fourth. All right, and then you got to go plus 6. All right, so there you go. Negative x plus 3 to the fourth plus 6. Okay, that's your new function. All right. For this one, it says the volume of a rectangle prism can be modeled by the function. Here's the function where v is in cubic meters and x is the length in meters. It says describe the transformation of v of 2/3 x by writing the new rule and explaining the change in the content of the problem. Okay, so check this out. Y'all see how this is 2/3 x, that's multiplied directly to the x's in the parentheses of the x. What that means is we're going to have a horizontal stretch, all right, by its reciprocal, which is 3/2. All right, we're going to have a horizontal stretch by 3/2. All right, horizontal stretch by 3/2 because remember you use the reciprocal. Now, you apply the 2/3 to all the x's directly. So you end up with 2/3 x cubed plus 3 times 2/3 x squared plus 2/3 plus 8. All right, so there you go. This will be your new equation, guys. And remember, all right, this right here, see how that's 2/3? All right, the reciprocal is 3/2. That's a stretch. All right, it's larger at the top, so that's a stretch, okay? So horizontal stretch. All right, this next one right here, it says graph this function. You can do that in your calculator, okay? And then it says describe the asymptote. Well, I talked to my students today, and hopefully you recognize this. This is an exponential function, clearly, because you have an exponent. This right here tells me my horizontal asymptote. All right, so I know just looking at the equation, my pen's on the fritz, guys, it's moving. All right, just looking at the equation, my horizontal asymptote right now is y equals -1. All right, because it's going to move down -1. And matter of fact, here, let me show you. All right, so what I have here is the original in the blue. That would be y, that would be, hold on, there we go, 5 to the x with no transformation. This would be the parent function. Now here's the equation we have, 5 to the x minus 1 minus 1. Well, this tells me move this whole thing down 1 unit, which the graph shows us down 1. All right, so y'all see how this is y equals 1 right here? It never crosses that. It just continues right there. All right, that's my asymptote, my horizontal asymptote, y equals 1. All right, so y equals -1 is my horizontal asymptote. Now, describe the how is the graph transformed from the parent function? Well, again, this x is directly this -1 is directly subtracted from the x. And the rule is you do the opposite when it's directly subtracted from the x. So we have x minus 1, which means to the right 1, okay? And then the -1 outside tells me down 1, okay? So these are the two transformations done to this parent function, okay? For this graph here, all right, it says find the asymptote, the y-intercept, and the asymptote. Well, here we go. Let's use our calculator again. Give me a second. Let me graph it. All right, so I entered this into our calculator, guys. All right, now hit graph. Let's see what it does. All right, there's our graph. All right, -1/2 raised to the x halves. All right. Now, when we look back, what did it ask for? The y-intercept. There's our y-intercept right there. Okay, now if you don't remember how to do it, a couple of different ways to see the y-intercept, guys. If you press second and graph, all right, remember your y-intercept is where x is 0. So 0, -1 is your y-intercept. All right, we can see that directly from our calculator. All right, so we go y-intercept, y equals -1, or you could say 0, -1. All right. Now it says, what's the asymptote? All right, what's the asymptote? Well, let's go back to our graph and have a look. Y'all see how, again, this is exponential, all right, because it has an exponent. This is going to get closer and closer and closer and closer to 0, but never cross it. So we're going to say our horizontal asymptote, y equals 0. All right. You also know, because let's take a look. See how this exponential function has a vertical shift down? See how this one does not have plus or minus? It doesn't have a vertical shift out here. There's not plus or minus something right here. So I'm going to say plus or minus 0. Well, remember, this is my my horizontal asymptote. So 0 is my horizontal asymptote. Just a couple different ways to look at it, man. Same thing. All right. Now, right here, 9, it says graph the logarithmic function. All right. Then it says find the asymptote and describe the transformation. If you guys remember, all right, about the asymptote, man, this is a log. If you remember in my Unit 12.2 video for log, I told you that this value right here tells you what your horizontal asymptote is. Your vertical asymptote, excuse me, vertical asymptote. Let me write that down. I keep saying it wrong. Vertical asymptote is. This tells me x plus 3, which means left 3. So my vertical asymptote is going to be x equals -3. And I'm going to show you this in the calculator, okay? All right. So I want you to see that this is 4/5 times the log of x plus 3 minus 2, okay? Now I'm going to go ahead and graph that. All right. And I want you to see how the calculator goes 1, 2, 3, -3, and it stops there. That's because there's an invisible line right here. All right. There's an invisible line right here. It goes straight down. I wish I could draw one right here. And you would be able to see it, but it stops right there at -3. Well, again, our function told us what the asymptote was. All right, -3, because remember, that's left 3. All right, so back to the calculator. 1, 2, 3. There's our asymptote, where this doesn't even exist anymore. It won't even graph it because there's an asymptote there, okay? All right, now, it says, so there's our asymptote. Now it says describe the transformation. This 4/5, all right, for our a value is less than 1. So that means we have a vertical compression. Ooh. Oops. There we go. Vertical compression by 4/5. All right, remember the rule right here is if it's larger than 1, it's a stretch. All right, if it's less than 1, it's a compression. And 4/5, that's not a whole pie you think about. You got 4 out of 5 slices of pizza. That's not the whole thing, okay? We know that since this is plus 3, we go left 3. Left 3. And then -2 means down 2. All right, so there's our transformations on this one. Next, number 10, it says write an equation for the function g of x, all right, in which the natural log of x is translated 3 units left, horizontally compressed by 1/4, and translated 0.5 units down, all right? So here we go. We have the natural log, okay, and a lot is going to happen right here. We got to translate it 3 units left, so that's x minus 3, because remember, you do the opposite. So -3 means right 3. Excuse me. Oh, actually, you know what? I made a boo-boo. It's plus 3 since we're going left. I was thinking right. It's plus 3 since we're going left, okay? So x plus 3 since we're going left. All right, then we got a horizontal compression by 1/4. Well, what's the reciprocal of this? All right, 4. So we're going to go 4x because that'll give us our compression by 1/4, okay? And then we're going to translate it 0.5 units down, so minus 0.5. All right, this, well, actually, here, let me clear that up because it looks kind of weird. 0.5. All right, here is our equation, all right, for g of x. All right. And then number 11 right here says write an equation for the function f of x, which is the exponential. This is e to the x, guys. All right. The horizontal stretch by a factor of 3, reflected across the y-axis and translated 1 unit right. All right, so here's the parent function, okay? We're going to horizontally stretch it by a factor of 3. So remember, again, horizontal stretch by 3, you need the reciprocal. So the reciprocal of 3 is 1/3. So that we're going to multiply that directly to our exponent. And then we're going to reflect it across the y-axis. All right, if I want to reflect across the y-axis, remember, you're going to multiply the x by a negative, okay? So that tells me reflect across the y-axis. And then we're going to move this whole thing to the right by 1. All right, so remember, the x is going to subtract 1. That tells me I move it to the right 1. So here's your equation right here, e to the negative 1/3 x minus 1. I'm just going to show you real quick. All right, so I'm going to go second and e, and we're going to raise that to the x. That's the parent function. All right, then we're going to go second and e again. All right, and this time we're going to go negative 1/3. Guys, I put parentheses around my fractions every time. All right, every time, so you'll be right. All right, minus 1, that'll give us to the right 1. So let's see. The parent function, here's the exponential right here, e to the x. And then we have the change, all right? Man, whew, that guy's this crap. Oh, man, hold on. Let me make sure it took. E to the negative 1/3 of x. Oh, you know what it is? Y'all see that? If you see it, awesome. It was supposed to be 1/3 x. Oh, come on, man. All right, hold on. Bear with me. 1/3 x. So there we go, 1/3 x. Now let's see what we get. This should make it a little better. There we go. So it reflected, right? It then moved over 1. It also compressed. Y'all see the angle here where it rounds, and over here it goes shoots up, where here it doesn't. It's kind of flatter. All right, it's a little wider. All right, so it compressed. So there we go. There's the change right there, okay? Well, hey, listen. I hope you enjoyed this. If you did, man, yo, shoot me a thumbs up on it, please. And go ahead and subscribe so that way you can get the links, man. All right. And hey, I wish you the very best luck on this exam. And man, I hope I am being helpful to you by making these videos, and I wish you the best, okay? Good luck, and I will see you guys tomorrow.